Hello students, welcome to AC Engineering. In this video, I am going to explain you the concepts of stability introductory portion, which is included in your 4th unit as a first topic. So while entering to the concepts, first we'll see the various definitions of an stability and accordingly the points one by one. So the term stability refers to the stable working condition of any control system. See, for every working system, it should be designed as a stable system. So if it is a stable system, the output or response is predictable while making and designing itself, and the definite and stable for a given input. So let us see the various definitions of an stability. So when we will see a system is a stable one. A system is stable according to the statement 1, definition 1, if its output is bounded means finite. Bounded means finite for any bounded input. Then the second definition, a system is asymptotically stable if in the absence of input at the same time the output tends to 0 with an important note irrespective of an initial condition. And we have 7 definitions over a stability, but the important 4 definitions that you have to keep it in your reference is the first one that just we crossed, and the last 3 definitions. So which one is limitly stable and which one is absolutely stable and which of the systems are conditionally stable. See, for a bounded means a finite input signal, if the output has constant amplitude oscillations, then the system may stable or unstable under limited constraints. This system is called as limitedly stable system. Similarly, if the system output is stable for all variations of its inputs, means parameters, then it is absolutely stable. When the system's output is stable for limited range of variations of its parameters, then it is conditionally stable. Then make a note of bounded input, bounded output stability, BIBO. See, when a linear relaxed system is said to have a BIBO stability if every bounded input results in a bounded output. So you just have a system with the BIBO stability means, according to the derivation, you just keep it in your mind this point. According to BIBO system, the system with the impulse response is BIBO stable if and only if the impulse response is absolutely integrable. So you just keep this point in your mind, and I will give you the introduction of all the things one by one. The next part is location of S-plane for stability. So here before we crossed a closed loop transfer function. It is a ratio of two polynomials in S. This denominator polynomial of the closed loop transfer function is characteristics equation that we will see in the second unit itself. The roots of this characteristics equations are poles of the closed loop transfer function. Then as far as BI-BO stability, the integral of impulse response should be finite, which implies that the impulse response should be finite as t tends to infinity. See, let us consider a closed loop transfer function. Here, closed loop transfer function, let it be some equation m of s equal to b naught s power m b1 s power m minus 1 according goes on up to bm. Then in a denominator, the denominator polynomial is called as a characteristics equation. This one is characteristics equation, where a naught s power n, a1 s power n minus 1, a2 s power n minus 2. It goes on. Means it is s plus z1, s plus z2, s plus z3 up to s plus z power zm. Means the numerators are zeros and the denominators are poles. So the roots of the numerator polynomials are zeros. The roots of the denominator polynomials are poles. The denominator polynomial is called as an characteristics equation. You just freeze this point in your mind. With this, you have to keep in a mind for while doing an problem. These are all the summaries stated depends on the location of an characteristics equation. See, when you have stated and integrating the stability of the system depends on the location of the roots of characteristics equation, then these 3 points are, keep it in your mind. What are they? The first one, if all the roots of a characteristics equation has negative real parts, then the system is stable. Listen, the roots of the characteristics equation has negative real parts, then the system is stable. Then second point, the roots of the characteristics equation has positive real, or if there is a repeated root on imaginary axis, then the system is unstable. The characteristics equation has positive real part or repeated roots on imaginary axis, then the system is unstable. Then third point, if the condition is satisfactory except for the presence of one or more non-repeated roots on imaginary axis, then the system is limitedly or marginally stable. So there are three conditions, keep it in your mind. When the system is stable, when the system is unstable, and when the system is limitedly or marginally stable. Then freeze your focus towards the introduction. Then with the summary, according to the conclusions can be made about the coefficient of characteristics equation. There are three possibilities to refer. First point, if all the coefficients are positive and if no coefficient is 0, then all the roots are in left half of S plane. I will repeat again. If all the coefficients are positive, then no coefficient is 0, then all the roots are on left half of S plane. Then second point, if any coefficient AI is equal to 0 and some of the roots may be on the imaginary axis on the right half of the S plane. Then third point, if any coefficient of AI is negative, then at least one root is in the right half of S plane. So this is an important point to note. So the necessary condition for stability of a system is that all the coefficients of its characteristics polynomial should be positive. If any coefficient is 0 or negative, we can immediately say the system is unstable. At the same time, in order to have all the roots have a negative real parts, it is necessary that all the coefficients of the characteristics equations are positive. But it is not sufficient because there may be roots in the right half of the S plane and the imaginary axis. So even when the coefficients are positive, when roots have negative real parts, then all the coefficients of the characteristics polynomial will be positive, but the reverse condition is not always true. So which you can easily understand from this one. All the roots in the real parts are always, all coefficients are positive, that's always true. But not all the coefficients are positive, then the roots are negative real. It is not always true. So you just keep focus on this point. Don't worry, while you are moving with an problem side, you can easily understand what it is. Now we will see what is Routh-Harvard's criterion. So this is simply an analytical procedure for determining whether all the roots of the polynomials have negative real parts or not. Then only we can easily customize the system given in an problem is stable or not. So for that we can consider only the characteristics equation. So this is what an Routh stability criterion as an introductory level. It's an analytical procedure for determining all the roots of the polynomials have negative real part or not. Then statement we'll see later. So while doing this justifications over, you can do step-by-step procedures. In first step, in analyzing the stability of a system, first examine its characteristics equation. What is characteristics equation? The denominator is in a transfer function, the denominator gives you the characteristics equation. Then what is the necessary condition for stability? It's that all the coefficients of this polynomial should be positive. If some of the coefficients are 0 or negative, then we can conclude that it is not stable. So all the roots should be positive only. Then when all the coefficients are positive, then the system is not necessarily stable. Just before I explain, once again I recollect the points. Even though the coefficients are positive, some of the roots may lie on the right half of the S-plane or the imaginary axis. In order for all the roots to have the positive real parts, it is necessary but not sufficiently that all the coefficients of the characteristics equation be positive. So I don't want to confuse you again and again. You just freeze the point. We need an positive coefficients. That's all. Then while discussing in problem, I will explain you one by one. And this is an array structure we need to form while solving an problem. This is what we called as an Routh stability criterions based on ordering the coefficients of the characteristics equation, and this is called an Routh array. See, if you have a characteristics equation like this, first start with an S bar n here, S bar n. The coefficient of S bar n is A0. So A0 means S bar n means S bar n minus 0. You can consider it as S bar n minus 0. Then next S bar n minus 1, S bar n minus 2, S bar n minus 3. It goes on up to last one, S 0. Then this is a statement of an Routh stability criterion up to what we discussed so far is consolidated here and given as a statement. The necessary and sufficient condition for stability is that all the elements in the first column of the Routh array should be positive. Keep it in your mind. First, write the characteristics equation. From the characteristics equation, form the Routh array. Then the first column of the Routh array should be positive. If this condition is not met, then the system is unstable. And the number of sign changes in the columns of the in the elements of the first column of the Routh array corresponds to the number of roots of the characteristics equation in the right half of the S-plane. See, what is given means the most important, necessary and sufficient condition for stability of a system is that by analyzing the Routh array, first column of this Routh array be positive. If this condition is not met, then go for the next one. Decision made that the system is unstable. If it is not positive, first column elements not positive, then the system is unstable. And the number of sign changes of the elements of the first column of the Routh array. So there should be some sign changes. That sign changes corresponds to the number of roots of the characteristics equation in the right half of the S plane. So what are all the sign changes? What are the points we need to keep in mind is, if the order of an sign of the first column elements is plus, plus, minus, plus, 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 minus, plus and plus, then plus to minus is considered as one sign change and minus to plus as another sign change. Now I will explain you how to consider two consequency rows of an Routh array and find the elements of all the S coefficients. Now consider two consecutive Routh array are like this. Now the next row B means if it is in first row, then it is in second row. How to construct the next row? Fine. The first row constituted with an coefficients of x0, x1, x2, x3, x4, x5 goes on. Then similarly next row S bar n minus x minus 1 is y0, y1, y2, y3, y4, y5. Then how to find the next row means S bar. How to find the next row means S bar n minus x minus 2. So which we called here as Z1, Z0, Z1, Z2, Z3, Z4. Fine. Now we are I am going to explore you how to find these Z values. See, the Z value 0 means Z0 is equal to minus 1 into, see here, see the first two columns, minus 1 modulus of x0, x0, x1, x0, x1, y0, y1, y0, y1 divided by this y0, divided by this y0. So how to find the value? See, we are all well known that it is modulus y0 x1, then x0 minus x0 y1 divided by y0. Similarly, we could find Z1. How to find Z1? How to find Z1? So that we consider x0, y0 and x2, y2. Construct an modulus of minus 1, modulus of x0, y0, x2, y2 divided by y0. Similarly, how to find x2? How to find x2? Minus 1, this one, x0, x0, y0 and x3, y3 divided by y0. x2, sorry, here that likely Z2 and Z3 goes on. So the elements are calculated like this. Then the three important cases for constructing an route array. The following 3 cases should be known to everybody. So case 1, normal route array means non-zero elements in the first column of the route array. Case 2, a row of all zeros. Then case 3, first element of a row is 0 but some or other elements are not 0. Fine. So in the next video I will explain you each and every cases with one example problem, 1 or 2 example problem. So you just refer the video again and again. So this is only the introductory portion for your understanding purpose. Next video gives you the case 1, case 2, case 3 as an individual videos with the solved problem. Thank you students, thanks for your support and sharing the content to your subject students also. Thank you students.